so we're on page 39. Remember, complete A, B, and the habits of mind. We'll go over all those in just a minute. Show of hands. Who's still working on this page? Okay, another couple minutes. All right, how are we looking? Who's still working on it? All right, let's go over it. So it says Juan analyzes the diagram to see if line L is parallel to line M. His teacher asks if there's enough information to say whether the lines are parallel. So yes, if a transversal intersects two parallel lines, then alternate interior angles are congruent and corresponding angles are congruent. I have both relationships here, so the lines are parallel. So what do you guys think? Is his statement correct or incorrect? Show of hands for totally correct. Juan is a genius. How many were like, no, Juan's got some issues? Really? Come on, guys. Let's try this again. How many are like, yep, Juan, you got it, man. I got one person, two people, 3, 4. That's a little better. Okay, how many are like, nah, not so much? All right, well, Juan is correct. All right, can you use alternate exterior angles theorem to prove that the lines are not parallel? Yes or no? No. Why? Go ahead. Yeah, so can't use it. There's a lot of reasons no here. This is just happens to be one of them that I said, and what you said is perfect too. So no worries. Okay. How about the habits of mind? So we have here, would Juan's statement be correct if he had referred to corresponding angles instead of alternate interior angles? What do you guys think? Let's think about what alternate, we're looking at corresponding angles here. What do we have to have in order to prove those congruent? We have to have what? Begins with a P. Go ahead. We have to have parallel lines. Did they state in this original problem that there are parallel lines? No. So he can't use this because of that. You have to have parallel lines in order to have these angles exist. Now you're probably looking at me like, Smith, what's the big deal? Okay, so here is the big deal. 2-1 went over, if you have parallel lines, you have certain rules that exist when that transversal goes through them, right? All those angles that end up existing. Same side interior, alternate exterior, alternate interior, and corresponding, right? And those help prove that those were either congruent or supplementary. Now, we're going to do the opposite. Given the angles, we're going to start proving the lines parallel using those converse rules. You guys remember the converse? Okay. So, take out those half sheets that I just gave you. There are 6 new rules that we are going to have to apply here. Okay. The first one, if we take a look, is converse of corresponding angles theorem. They're saying if you are given that corresponding angles are in fact congruent, then you have parallel lines. The converse of alternate interior angles theorem states that if you have alternate interior angles congruent, then you have parallel lines. The converse of same side interior angles postulate states that if you have same side interior angles supplementary, then you have parallel lines. The converse of alternate exterior angles theorem, if you have alternate exterior angles congruent, then you have parallel lines. So these are the first 4 new ones, okay? Now the second part, if we take a look here, theorem 2.8, it says if 2 lines are parallel to the same line, then they are parallel to each other. So if you look here, B and C are parallel, A and C are parallel, then by definition, A and B also have to be parallel, okay? There is no name for this. Do you guys notice that? It's just called theorem 2.8. We cannot call it theorem 2.8. We have to write out this whole thing if we use it in a proof. Okay? I cannot stress it enough. You have to write this one if you use it in a proof. Theorem 2.9, if 2 lines in the same plane are perpendicular to the same line, then they are perpendicular to each other. So what they're saying here is if you have 2 right angles, then A is parallel to B. So again, that's kind of like a shortcut for proving the lines parallel without having, because we know all right angles are congruent, so that works. But again, 2.9 is kind of the same way as 2.8. If 2 lines in the same plane are perpendicular to the same line, then they are parallel to each other. This one and this one, you must write out. No name exists. No, we will not be creating a name either. Okay? Do not call it theorem 2.8 in your proof writing. That is a big no-no. The reason for that is that every book labels these things differently, but the rule itself is still the same. This could be a chapter 3 in another book or a chapter 5, and they would call it 5- whatever. That is not an actual name, okay? It's just a way to label it, so this way you know what part of the book you're in, okay? Questions on this? Anybody still writing here? All right, I'm going to erase this, and we're going to move on. All right, so flip over that half sheet. We're going to work on these additional examples. Now, I'm going to do it one way. That does not mean that is the only way. This is just how I see it, okay? So please keep that in mind as we're working on this, because you could see it a completely different way, and that's totally fine. So it says, is it possible to prove that lines P and Q are parallel? If so, explain how. So looking at this, I see a couple of different ways of doing this. I can look at this as a linear pair, but I'm just looking at these as vertical angles. So I'm just going to write 124 here. Now I'm going to check to make sure that these two are supplementary. So 124 plus 56 is how much? It's 124 plus 56. Good. 180. Since they are supplementary, I can state without a doubt that P is parallel to Q by the converse of same side interior angles postulate. I know that seems like a lot of writing for a rule, right? But I want you to think of it this way. If these names didn't exist, you'd be writing the if-thens for everything, just like you did with theorem 2.8 and 2.9. Okay? So keep that in mind. Like, this might seem like a lot, but it's really not that bad. Okay? All right. Let's take a look at number 2. So the first thing I'm going to do is I'm going to check, because I'm looking at kind of this line, and here's my transversal. So first thing I'm going to do is I'm going to look at the 58 and 74. I'm going to add those up. What does that equal? Good. That equals 132 degrees. So this whole thing is 132 degrees. So what kind of angles do I have here? Corresponding angles. So I'm just going to state that P is parallel to Q by the converse of corresponding angles theorem. Questions? All right, let's take a look at number 3. So here I have a triangle, which is kind of nice because I can find this angle. Well, first off, how many degrees is a triangle total? Good. 180. So I'm going to take 180. I'm going to subtract 48 and subtract 79. What does that leave me with? Good. 53 degrees. So since this is 53, that's 53. What type of angles do I have here? Good. Alternate interior. Very good. See, I'm looking at this one, and there's my transversal. So those are congruent. So I can state that P is parallel to Q by the converse of alternate interior angles theorem. Yes. You can. Yeah, that should equal. But does that equal 180 is the question. Yeah. Oh, I see what you're saying here. You mean if you just talked about that whole line? You cannot do that. So you're talking about like if this is 79, you add this, and this whole line equals 180? No, you have to have an angle that touches the first line and the second line for that to be proven parallel. All you did there was prove that they're supplementary. Okay. Good question, though. Any other questions? Okay. Let's move on to, all right, so here's kind of the takeaway from this that I want you guys to state. The theorems, oh my gosh, what happened this didn't jump? Theorems and postulates without the converse proves angles, whether they're congruent or supplementary, okay? The converse proves parallel lines. That is a big key. So anything that has the if you are proving parallel lines, you are saying the converse of. Yes. Theorems and postulates without the converse proves angles. I have it up there. And then the converse, if you have to prove parallel lines, you have to add the converse of. All right? Questions on this? So think of it this way. If you're given parallel lines, just use the straight theorems and postulates. If you're not given parallel lines, use the converse. Okay? Does that make sense? That's kind of the pattern. That's the only pattern I got for you with this stuff. Sorry, guys. Is what it is. All right. Safe to move on to the next page. All right, let's take a look at those ones below. All right, so it says, for the following problems, use the given that P is parallel to Q. All right, so I'm just going to mark that real quick. Here's P parallel to Q. And then I'm also given that Q is parallel to R. So by definition, are P and R also parallel? Yes or no? They are, right? So all three of these are parallel to each other. That would be by like that 2.8, 2.9 rule, right? And you have to write it out completely if it isn't a proof. The other thing they're telling us is that AB is perpendicular to R. So we have a right angle right there. And the measure of angle 1 is 54 degrees. They want us to find the measure of each angle. So angle 9, angle 6, and angle 4. So here are the two angles. Angle 4, angle 6, and angle 9. Okay, so if I looked at this a bit more theoretically, okay, and I ignored this part right here. So if I focused in on angle 4 is going to be the easiest one to look at, right? Why is angle 4 the easiest one to find right now? Who can tell me? Go ahead.
Closest in relation to the measure that we have, so we have less steps to go through.
That's one reason. Very good. What else? What if I focused in just on this line, and this was my transversal? What kind of angles would I have there? I'm just gonna kind of white this one out. We're gonna ignore that one just for a little bit. Okay. What kind of angles do I have here and here? Tyler or Reese, you got it? For this guy and this guy. I got a 90-degree angle. Yep. Okay, so I'm gonna mark it. But why? I have these two parallel lines. Here's my transversal. What kind of angles are these? You don't necessarily have to write out everything. There's multiple ways to approach this. We know that all right angles are congruent, right? We have a rule on that. So what type of angles are these? corresponding? Are they same side interior? You got it? Yeah, you can just state that this is, 90 degrees. By, now am I going to state that it's the converse, or am I going to state that it's just alternate interior? Let's see who's paying attention. What do you guys think? 50-50 shot. You don't even get odds like that in Vegas. You know it? Which one? You don't know? Take a guess. Am I using the converse or am I not using the converse? Not. Very good, because they gave me the parallel lines. So this will just be by alternate interior angles theorem. Very good. All right, so now that I have that, angle 6 is probably going to be the better one to work with right now, okay? So what I'm going to do here is, again, I'm going to just kind of white out the one that we don't really need, okay? And in this case, the one we don't really need is this bottom one right here. So I'm just going to white that out. We don't need that one right now, okay? And I'm going to focus in on this line and this parallel line. Again, now with this is my transversal. And I need to find 6. How am I going to do that? Go ahead. Okay. Okay. So you're trying corresponding angles. That's a good way of looking at it. Give me another way of looking at it.
You could say that the measures of, or angle 1 and angle 2 are vertical angles, and you could use same side interior angles to find angle 6.
Perfect. Both are good. Okay. Reese said, hey, if this is 180, I can subtract 180, find this, and then these are corresponding angles. Totally fine. Okay. The other way, these are vertical angles. These are same side interior because the lines are parallel. Subtract 180, I still get the same result, right? It's just the rule's a little different. I'm just gonna do the same side interior approach. No real reason, just that's what I saw first too. Okay. All right, so now I'm gonna take 180, subtract that from 54. What am I left with? In the world of technology, not one person has a calculator out? Come on, guys. We got this. We have the skills. We have the technology. Yes. 126. So this one's 126 degrees. And all I'm going to state is that this is by same side interior angles postulate. It's kind of weird working in reverse, right? Sometimes aren't you guys like really used to like going, okay, here it is, and going down the line, right? In geometry, it's okay to work weird. It's okay to go backwards. Okay, always solve for what you can find first. All right, let's take a look at this last one, the measure of angle 9. Okay, so I need this line back. I am going to use this line, but I'm just going to give it a different color. But this guy, boop, that's gone. So this is the one I'm ignoring right now. Okay. So here's my one. Come on now. Let's do this. There we go. Here's my parallel line. Here's my parallel line. Again, here's my transversal. Now I have that this is 126. I need to find 9. What do I do? Reese, go ahead. Mm-hmm. Okay, so those are parallel lines. So we have that's 126. What does that make for 7 then? Okay, so it'd be 180 minus 126. That gives me 54. This is 54. And then I have what types of angles here? Here's an A. Alternate interior or exterior. There's only two, so very good. So we're just going to state that this is 54 degrees by alternate interior angles theorem. Okay. Okay. So for letter D, it's saying, is P parallel with R? Why or why not? And we already kind of talked about that. Yes. And we would state by that theorem 2.8, but we're not going to call it theorem 2.8, right? We're going to state if two lines are parallel to the same line, then they are parallel to each other. I know that seems crazy. Yes.
So if you were to write that out as like an equation, like P is parallel to Q and Q is parallel to R, did you use the transitive property there?
No. That's a good question. It seems very transitive, right? The problem is there's two transitive properties. One is of equality, where you're talking about physical numbers or variables. And then there's one of congruence. There's not the transitive property of parallel lines because you can't, lines don't have a measure. So you can't state if lines are congruent or not. You can state segments are. You can state segments are. You could state angles are, but you can't state physical lines are congruent or equal. So that's why there's no transitive property of parallel lines. Does that make sense? So yeah, no, you can't use you can't. It's very tempting. I get it, and I get this is a lot of writing, but yeah, you can't. Any other questions? Good question, by the way. Okay. Anybody still writing? All right. Let's click screen. Okay, so again, that's when you don't have to write down. I would start drawing this picture though, because you are going to need it for example 1 for the try it. So it says, what angle relationships can be used to prove that two lines intersected by a transversal are parallel? The answer to this, we already kind of went over it, is your converses. Okay? So understand angle relationships, suppose two lines are not parallel. Can corresponding angles still be congruent? Draw two non-parallel lines T and M and a transversal S. Draw a line L parallel to M that passes through the intersection of S and T. If you guys look here, you see how this is a dashed line? This is known as an auxiliary line. This is something that you add in order to prove something. Okay? It doesn't originally exist. That's why it's dashed. Think of it as like, you guys remember when you did inequalities, and if you didn't have that equal sign, you had that dashed line, same kind of concept. It's not really there. You're using it just to prove something, okay? And if we were going to put this in a proof, we would be add auxiliary line, we're going to call it L, okay? And the statement would be draw L, okay? All right, so now that we have this, we're stating that, okay, we have this whole thing, and our transversal here is supposed to be S. Okay. So they're saying since L is parallel to M, the measure of angle 1 is equal to 120. By the corresponding angles theorem, so this and this, angle 1 would also have to be 120. But if we take a look, by alternate interior angles theorem, the measure of angle 2 would equal x here. Since the measure of angle 1 plus the measure of angle 2 is supposed to equal the measure 120 plus x, the measure of angle 1 plus the measure of angle 2 would have to be 120. That's or greater than 120. That means that these two lines are not parallel. Okay? So that means corresponding angles in this case would not be congruent. Any questions on that before we move on to the next slide? Okay. Let's take a look at the you try it. Could 3 be supplementary to the 120 angle? Explain. All right, so you guys should have this drawn out. Let's take a look. So again, they're stating that this is parallel to this, and they're asking, hey, can angle 3 be supplementary to this? What do you guys think, just looking at it? How many think, yeah, they could be supplementary, why not? How many of you are like, no, there's something funky going on here. They can't be supplementary. The quicker we get through this, the quicker we can stop. You guys can start on your homework. So let's try this again. Can 3 be supplementary to 120? Yes or no? Show of hands for yes. Show of hands for no. Okay. No, it can't work. Here's why. If you guys look at these parallel lines and you say just 3 is supplementary, what's going on with 2? You got something else going on here. So that's actually one of the reasons is that you have this combination of 3 and 2, and so 3 can't be just the only thing that's supplementary to it. Okay? That's one of the reasons. Here's the other reason using inequalities. S and T form a triangle. The sum of the interior angles of a triangle is 180 degrees. So you have 120 here. That means 3 plus 120 has to be less than 180. And that's going to be a tough, it can't be supplementary to this and have it equal 180 for this triangle to exist. So that's another reason, okay? So many ways of seeing things. Questions on this? Anything? All right. I want you guys to turn page 42. All right. I want you to work on 5, 6, and 7 for a few minutes. We'll go over that. And we'll be good. Show of hands who's still working on these. Okay, another minute. All right, show of hands if you're still working on these. All right, big reveal, number 5. Oops, there we go. Converse of alternate interior angles theorem to prove that the two lines are parallel. If the measure of angle 2 equals x minus 6 and the measure of angle 3 equals 2x plus 18, for what value of x is A parallel to B? Which theorem justifies your answer? Who has the answer for x? Good. 12. And what's the theorem?
Converse of alternate exterior angles.
Nice. And then using the converse of the same side interior angles postulate, what equation could be used to prove that G is parallel to H? So here's G, here's H. There was 2 options. Good.
Measure of angle 1 plus measure of angle 3.
Very good. What's the other one?
Measure of angle 2 plus measure of angle 4 equals 1.
Perfect. Questions, comments, concerns, snide remarks. All right, hop on to Realize. You guys can work on your homework. I think there's like 9 questions. 9. That's about it. All right. Those of you watching at home, have a great day.